Good morning, Mr. Gopi, and good morning, classmate. I'm Elizabeth, and I'm here with my group mates Audrey, Catherine, and Jasmine to present about Group 17. As we go down the group, the color of halogen will become darker. On moving from fluorine to iodine, the atomic radii increases, so the energy level becomes closer and the low energy light, higher wavelength, is observed and color deepens on moving down the group. You can see from the pictures that fluorine is pale yellow while iodine is black solid, so we can see how the color gradually deepens. The melting and boiling points of halogen increases down the group. This is because of the van der Waals forces. The size of molecule increases down the group. This increase the size means an increase in the strength of van der Waals forces. Hence, it requires more energy to overcome these van der Waals forces. The volatility of halogen decreases going down the group. The boiling point data give us an idea of the volatility of the halogens. There are only weak van der Waals forces between their diatomic molecules. These forces increases as the number of electrons in the molecule increases with increasing atomic number. The greater the number of electrons, the greater opportunity for instantaneous dipole arising within molecules, and for induced dipole to be produced on neighboring molecules. So the larger the molecule, the stronger the van der Waals forces between molecules, making iodine the least volatile and fluorine the most volatile of the halogen we're considering.
The reactivity of halogens decreases down the group. This is because atomic radius and shielding effect increases down the group, causing the force of attraction between nucleus and valence electron to decrease. As a result, it is harder for the halogens to get an electron. Fluorine is the most reactive halogen, followed by chlorine, bromine, iodine, astatine, and tennessine. The following graph shows the trend of electronegativity of group 17. The graph shows a general decrease because as atomic radius and shielding effect increases, the force of attraction between the nucleus and valence electrons decreases. This decreases the atom's ability to attract shared electron to itself. When bromine is added to sodium iodide, the bromine will displace the iodine because it is more reactive. The displacement reaction will cause cyclohexane to change color from brown to purple due to the dissolved iodine. Cyclohexane is a solution used to differentiate between chlorine, bromine, and iodine. In the presence of dissolved chlorine, color will be pale green, dissolved bromine will be orange, and dissolved iodine will be purple as shown in the picture.
Halogens react with hydrogen to form hydrogen halides. Going down the group, the reaction becomes less reactive and less vigorous. Going down the group, hydrogen halides become less thermally stable. This is because going down the group, size of halides are getting bigger, so the bond length increase while the bond energy decrease. So this requires less heat energy to break its bonds, making it less thermally stable. To test for halite ions, we first dissolve unknown compound in dilute nitric acid and then add silver nitrate. If a precipitate forms, then the compound contains halite ions. For chloride, it will form a white precipitate, for bromide cream and iodide yellow. Because the colors are so similar, we add dilute ammonia solution or a concentrated ammonia solution to find if it's a chloride, bromide, or iodide ion.
Concentrated sulfuric acid is a strong oxidizing agent. Sodium iodide or sodium bromide reacts with sulfuric acid, producing hydrogen iodide or hydrogen bromide. Hydrogen iodide and hydrogen bromide easily decomposes. Thus, it will continue to react with the sulfuric acid. Sodium bromide reacts with sulfuric acid to form sodium bisulfate and hydrogen bromide. Hydrogen bromide reacts with sulfuric acid to form bromine, sulfur dioxide, and water. Sodium iodide reacts with sulfuric acid to form sodium bisulfate and hydrogen iodide. Then, hydrogen iodide reacts with sulfuric acid to form iodine, sulfur dioxide, and water. In this reaction, a purple vapor is observed. Or, hydrogen iodide reacts with sulfuric acid to form iodine, sulfur solid, and water. In this reaction, a yellow solid is observed. Or, hydrogen iodide reacts with sulfuric acid to form iodine, hydrogen sulfate, and water. which produces a rotten egg smell because of the hydrogen sulfate. Chlorine and cold alkali in 15 degrees Celsius. Chlorine is reacted with sodium hydroxide to form sodium chloride, sodium hypochlorite, and water. Chlorine's oxidation state changes from 0 to -1 and from 0 to +1. Chlorine in hot alkali, 70 degrees Celsius. Chlorine is reacted with sodium hydroxide to form sodium chloride, sodium chlorate, and water. Chlorine's oxidation state changes from 0 to -1 and from 0 to +5.